Hello everyone, welcome you again, and let me discuss with you one more interview question which was asked in one of the interviews for basically for MS program in one of the IITs, and the question was, does strain energy depends on volume or not? That was the question. Okay, so you could have approached it in two ways, like either if you know the direct formula of strain energy, then I think you can interpret it from there directly. Other way could be like if you don't remember the formula and if you start from basic by explaining, okay, and taking a few seconds to write it down, then I think that would be one more better way of answering the question, because in that case interview will think that okay, you are applying your basic concepts, you are thinking on it, and then you are trying to reach the solution. And in any of the interviews, as you know, when we talk about the research organization or whether for MS, PhD or MTech programs in IIT, the approach is seen that whether you are applying the concepts or not. And if you will adopt that approach, you are going to get the advantage. It is not simply the cramming of the formulas that is they want to check. Okay, they have already checked that part in your like examination through GATE or other examination that you appear for. Okay, now first of all let me explain you what is the strain energy. All of you may be knowing strain energy. When we say that okay, it is the energy stored in the material when we deform it, when we strain it, right? So for example, if I say that okay, this is a material, if I slightly, let's say within the elastic limit, if I pull it, then okay, whatever the force or whatever the external work that you did, that basically goes in straining the material, in deforming the material. So that energy or that external work that you have supplied basically gets stored within the material in the form of strain or deformation. When you will release that load, as you know, within the elastic limit, material will come back. So how it came back? It came back because whatever the work that you had supplied externally, when you will release that load, immediately that work will be regained, as it will be, that material will regain its shape. So basically at molecular level, basically you are trying to change the distance between those molecules or atoms when you apply the force, and when you release the force, it will come back again to the same position. Something that way you can understand at a very elementary level if you say that what is strain energy. So strain energy is simply the energy stored in the material when we strain it, when we deform it. Now how to find it out? So we will say that okay, as I said while explaining, that strain energy is basically equal to the whatever the work that you have done externally. And if I ask you how you find out that work done, you will say that whatever the force that you applied, if you multiply it by the distance, in this case the distance is going to be the deformation that you have caused. So force multiplied by distance, it is going to give you the work done, as simply as that. So can I say in that case, and which you may already be knowing, the energy, that is the strain energy, basically how do we say? Strain energy is equal to the external amount of external work done, as simple as that. Now point is that how much work you have done. So normally when we talk in the context of for example, if nothing is specified, particularly in the strength of material, when we talk about, or in design, in nothing is specified, we say that okay, that load is being applied gradually. For example, had I applied a load, let us say if I am having a this bar, and let us say if I am applying a load, constant load. Now important is load, this is the constant load. Let us say applying this load 10 kilonewton as a constant load. That means from the start to the end, when it got deformed to, let us say, a particular amount delta, this bar. So if I say what is the work done, you will say, because if I draw the force deflection diagram in this case, you will say from the very beginning I applied a load when deformation was 0 almost and started deforming it. I applied a load 10 kilonewton and went on till I got the deformation, let us say whatever amount that I am saying, that is delta. So how much work you did? You will say, either will say force multiplied by deflection. So or indirectly you can also say it is the same thing as if it is the area under the diagram in the force deflection diagram. So what is the area under the diagram? It is a rectangle, because constant force you are applying till you have obtained the deformation delta. So can I say in this case, when I am applying a constant load, I can say the external work done in that case will be force into deflection, right? But if he has not specified anything, and particularly when we talk about in strength of material, like normally when you say tensile test and all that, normally you apply the load gradually, right? You say okay, that okay, I give you a bar and you start deforming it, for example in a tensile test or something, then what do? You apply the load gradually. That means this load that you applied over here, 10 kilonewton, which I am showing over here, this is not the constant load that you applied, but you applied that load gradually. Initially you may have applied 1 kilonewton, 2, 3, 4, and finally the maximum load that you obtained was 10 kilonewton. And when we plot this information, in the stress strain diagram, not stress strain diagram, force deflection diagram, let us say, which you get in the UTM. You know, in universal testing machine also, when you deform, or let us say deform that material, elongate, let us say it's a tensile test, then that particular machine will give you force deflection diagram. And you know that force deflection diagram also is something like this way, similar kind of like stress strain diagram at later stage which we obtain. But as of now, let us say I am deforming it, let us say within the elastic limit. I am not talking about other things as of now. So you will obtain something. That means as you will increase the load, deformation will increase. As you go on increasing the load, if I increase the load, amount of deformation will be corresponding to that. That will be this much deformation you obtain. As you increase the load further, then amount of deformation corresponding to that is going to increase, right? That means as I am increasing the load gradually from 1, 2, 3 to and finally 10 kilonewton, the deformation also goes on decreasing, and I am having something this way. Now in this case, if I ask you what is the external work done, कितना काम किया आपने इस केस में? Earlier case I told you simply rectangle. So in this case, for example, if I applied a force P over here, corresponding to that you obtain the deflection, let us say delta over here. So I will say I applied a load, let us say P. This is the force axis. So let us say if I applied a load P over here, and corresponding to that P, let us say 10 kilonewton or whatever, corresponding to that this much deformation you obtain. Since the load was being applied gradually, you obtain this kind of line, that is linear variation within an elastic limit. Then I will say again over here, can't I say that this is the area under the diagram in force deflection diagram? Of course. Then you will say what is the area of this diagram? So you will say this is a half of P into delta. Over there it was in earlier case when I was applying the constant load, then it was a rectangle only. So in that case I had no option but P into delta, that was the work done. Over here it is a half of P into delta because it is a triangle. So can I say over here external work done, how much you did? Whatever the external work you did, basically that got stored in the material in the form of strain deformation, right? So that means half of P into delta. That's all. From where you got? From this understanding, because you have the understanding that okay, I am applying the gradual load. If he doesn't specify anything, then my understanding or your understanding is to be that I am applying the gradual load only. Otherwise you should clearly specify what kind of load you are applying, impact load, sudden load, what kind of load you are applying. So if that be the case, let us say in this case, now we are having half of P into delta. Now you already know this is change in length, right? Deformation means change in length only of that particular bar or that component or whatever you say. Let us say I am saying this much. How you write it delta? That is change in length. This is change in length only, or in simple term change in length that you denote. Meaning is same. So if I say how do you write? You know PL upon AE. Stress strain relationship से आपको पता है ये that you know. Oh, sorry, stress is directly proportional to strain. Hooke's law within the elastic limit, that you know. So from there we have this one. So change in length becomes this much. So can I write this change in length over here this way? That is the half of P into what? PL upon AE. Right? Because delta is equal to PL upon AE. As simple as that. So now if I write it this way, that is half of P square. Now if I rearrange it, for example, if I multiply it by A and divide by A, then I am having A square down there. Since I multiplied by A down there, obviously I need to multiply over there with A. So I multiplied with A. So that means upon E. Same, no difference between this and this. Now can I write it this way? P by A, you know, force divided by area becomes stress. So this becomes sigma square. Down there it is 2. And over here E, modulus of elasticity is the property of the material, into A into L. And what is A into L? A is the cross-sectional area of that particular bar. Let us say A is the cross-sectional area of that bar in which I am applying force P, and L is the length of that bar, So what is that? This becomes the volume. So it means, can I say that strain energy which I have calculated over here is equal to sigma square by 2E into volume. So if you don't remember this formula, then what option you do have? Hardly it is going to take 20 seconds to write down this whole information immediately, because you are dealing with all these things very easily. Immediately you will draw and immediately write it down. So that will give you a very good impression on the interviewer also, that he will understand, okay, he knows the things, he is applying his mind and he is trying to reach that particular conclusion. Now you have the answer with you. Does strain energy depends on volume? Of course it depends upon the volume. Larger the volume of the material, larger is the strain energy stored in the material. That you can also interpret from here. For example, if I say I am having over here sigma, for example, for the same, for example, if you are having P for the same force and same cross sectional area, and Young's modulus is same. If I change the volume, right? If I change the volume, how I can change the volume? If you are saying that everything I am keeping same over there, now I am just making it bigger, same. You can interpret not only from here, from here also. For example, if I am keeping the same area, same force, I am applying the same force, okay? I am applying the same force, same cross sectional area. If cross sectional area is same, the only way, and E is the Young's modulus, so it is a property of the material for this as well as this, it is going to remain same. So this volume, how I can change? Since cross sectional area I am keeping the same, so I am changing the length. So if I am changing the length, then obviously what is going to happen is that your volume is getting changed, and so if volume is getting changed, then increasing, in this case it is increasing, then you will say strain energy is increasing, as simple as that. Or if you want to interpret it from here also, then also you can interpret it. If you see over here, can you interpret the same thing from over here, that by increasing the volume the strain energy is increasing from here also? Of course. You will say, had this been the situation, this one and this one. Now tell me, force, let us say here also you are applying the same force, here you are also applying the same force. So let's say this is same. Now since I have changed the volume, increased the volume, I have changed the length. So what is happening to the change in length in this case compared to that? You will say this, in this case when I will apply the force, same force, the change in length will be more compared to the change in length that I will obtain over here. That means if I increase the length of the same bar but apply the same force, same amount of force, the change in length that I will obtain over here will be more compared to that. So you will say how you came to that conclusion, that you can see it over here also. Change in length is equal to PL upon AE. So if you are keeping the force same force over there, here, same cross sectional area, E is the Young's modulus of that is Young's modulus of the material, because it is the same material. Then you have, if you will increase the length, change in length will be more here. If you increase the length, change in length will be more compared to this. So that means not only this, that formula that we have finally, I can also interpret from here. If you have that basic understanding of this, how that particular material behaves, or how you apply the force and how it is going to have impact on its change in length and all that. So this just I simply elaborated to you so that you have little wider understanding or wider dimension that you can get exposed to. But if, let us say, if you simply ask in the interview, not only in MS, he can ask this question in PhD also, in MTech also, on the similar lines. Important is your approach. So simply what you do, if you don't remember the formula, immediately apply the basic concept and try to answer it. So that way your explanation will also be better, and your impression on that interview is going to be far much better, and your chances of getting selected will also increase. So that is all in this particular video. In next video, I will be discussing more questions on the similar lines. So basic will be same, but he has framed for some other questions on the similar lines. So I think I will form the basis for, I will take the basis, this is the same basis, then some more questions I will be discussing from this particular topic. So see you in the next video. Till then, bye. Thank you.